So we have something that we call okay um, a logarithmic function. Here we're gonna talk about logarithmic function, right? So remember, in exponential functions, right? We put an exponent here, and then we get an answer, right? So let's say we put 3 there, and then we're gonna get what? We're gonna get 8, right? Now, in logarithmic function, we're gonna be asking we're gonna get asking how we're gonna be wanting to get this number, right? So we're gonna have log of base 2 that gives us it's gonna give us which exponent, right? So here we're looking for exponent. Here we were looking for what? For 8, right? So here we're gonna ask ourselves for what power must I raise the base 2 to get this number, right? So an exponential function, we put a number and it grows, right? Exponential function, we put a number and it grows. So here we're gonna be like, okay, what power must I raise my exponent to? Must I raise my exponent to? Must I raise my exponent to? Right? Oh, okay, to get this number. Right? So I'm gonna get which exponent did I square, did I powered to 2 to get 8? Yeah, it's like that, right? We want the exponent, right? That's what happens with logarithmic functions, right? So we have got log of a, the power of x is equals to y, right? This is what this is like our main rule for logarithm, right? So what this one is asking is that what power of a is going to give us x, right? What power of 2 is going to give us 8, right? What power of a is going to give us x, right? So that's the main rule of logarithms, right? So you can make an example by okay, it's fine. We don't need to make an example. So let's come to graphs. Put my tablet this side. So here we're gonna have the graph of y is equals to log a of x with a is less than 1, right? So the thing is given along with the graph of y is equals to a to the power of x on the same set of x's. So what's happening here is that we have a logarithmic function as well as an exponential function, right? So they're there on the same set of x's, right? The same set of x's, right? So we know that one is our y is equals to a to the power of x. So this one is the inverse, right? This one is the inverse. Okay, right? That one is the inverse. And I have y is equals to log a x, right? That's for when a is greater than 0. Remember that when a is greater than 0, the graph increases, right? The graph actually increases. right? So remember in the inverse, our x becomes what? Our x becomes y, right? And remember, because this one is decreasing, it's increase. So it's decreasing on the negative side. So this one also have to decrease on the increase on the negative side, right? That's log ax. Then that's y equals to 8 to the power of x, right? Right. And then we have what we call a natural logarithmic function, right? We then we knew that it was a to the power of x, that e has the value of 2 point something, right? So that log of e, we write it as n, and then x is equals to log of e, the power of x, right? If x is greater than 0, right? So the natural log, logarithmic function is the inverse of natural exponential function, right? So we have got like some properties of logarithm where we have log a to the power of x is equals to y, and then we have got log a, the power of a to the power of x, right? And then we've got log a x plus log b a y equals to log a x over y. We have log a is equals to r log x, right? Then we've got log a is equals to 1, got log 1 is equals to 0. I've got log x, which is equals to log a above x equals to log b over log a, right? Ln of x equals to y. Now e the power of x is equals to x e to the power of ln equals to x. Then we have got what we call